Here is 10-97, letter C. On 10-97, it's about Antonio and Luann. It says Antonio and Luann are trying to explain a strategy for computing the sum of a geometric series. They decide to generate a sequence that will be easy to sum so they can convince their classmates that their strategy really works. They decide to use this sequence right here. So then I see, or this series right here. So the question was just about letter C. So letter C says, represent the first n terms of the series using summation notation, and then write an expression for the total sum of n terms. So I have it written down. I already wrote it down. So this is the series that they're trying to get summation notation for. So summation notation, this thing is a sigma, and it means you're going to sum up that you start it. Your book likes to use the letter I or the letter K. I just chose the letter K today. You start out with usually just the first term. Sometimes it's possible to start with the 0th term, but let's not get in the habit of doing that. So start with the first term, and then it's going to generate the second term and the third term and the fourth term, all the way up to the nth term. Now, we don't know what the nth term is, but you can still generate some terms, right? Because you can go, like if I wanted to start writing this series, the first term would be, let's see, 3 times 10 to the 1 minus 1 is 0. It would just be 3. And the second term would be, well, I think I'm just timesing them by 10. It would be 3 times 10 to the 2 minus 1. That'd be 3 times 10 to the first power, so that'd be 30. And then so on and so on. But the problem is I don't want to really try to write this whole thing out because it doesn't tell me where to stop. Well, it tells me where to stop at n. We don't know what number n is, so there's that problem. But what this summation notation does is it says go ahead and start going. Start with 1, then do 2, then 3, then 4. Always just adding 1 to your term number until you get to the end. This is always the end number. So they wanted the first n terms, so that's how this notation works. Okay. And then, of course, you just put your little equation in here. You just put, see, this is just that. That's the generator. It generates each one of the terms. So you make sure, and I always like to make sure it works. Like I'll generate a couple terms. Like generate the third term. When I plug in 3 here, I go 3 minus 1, that's 2. 10 squared is 100, and 100 times 3, that's 300. And I can see that it's working. So this is fine. This is the summation notation right here. So that's part of the answer. And then it wants, it also wanted something else. It wanted us to write an expression for the total sum of the n terms. So in the video, I think in the very last video that I published, or maybe a couple videos ago, we learned that the sum of a geometric series, you can use this formula, and this is in one of your math notes boxes. My page numbers are different than yours because you have 2 volumes and I just have 1, but there is a math notes box that has this formula in it. So A is the first term, and R is the multiplier. So in our case, A is going to be 3, and R is going to be 10. And this is how you can sum it. So I just plugged the numbers in. So there's A, and then 1 minus 10, because 10 is R, to the n, and then 1 minus R, well, R was 10, so I'm just showing my work here. Now, I kind of just liked it like this, but you could distribute the top and make it look more like this, and 1 minus 10 is -9. And then if you wanted to move the terms around and multiply the top and bottom by -1 so that you don't have that negative sign down there, you could just switch this around and make it look like this. This is what your answer key has. And so these are the two answers that your book is looking for.